on this computer. So I have a recording button. Does it show that it's recording on your end? Perfect. Okay, so here's your warning. This lecture is being recorded. So you may want to turn off your webcams and audio if you don't want to appear in the YouTube video. Okay, so last week we were talking about selection, right? So I said there are three things that you have to have in a programming language in order to sort of compute everything, right? Everything else sort of becomes redundant. Sequencing, that is the notion that Python code is ordered and sort of executes from top to bottom, line by line. Two, selection. Selection allowed us to sort of do branching, right? To skip over parts of code or to force the code to go in one of several directions. So the third thing I had to teach you was iteration, repeating. Now, there are two types of loops in Python, and we're going to focus on only what we call the while loop, because we'll find that one of them is sufficient. The other thing is just sort of a shortcut. And speaking of that, I sort of have a better understanding now of what I'm supposed to be teaching y'all. And it seems that you are restricted to a very small subset of the Python commands, and we're going to just utilize those. So you have to know that when I'm programming, I'm not necessarily doing it what I would qualify as like the best way. We're going to do it the best way that we can using the tools that you've been limited to, which is like an informative exercise. Because again, you only need three things to do everything. So this will give you an appreciation if you go on further and when you start finding some of these language patterns have been simplified. So again, I'm just going to try to remember to restrict myself to the stuff that you're supposed to be learning, because I've been told somehow that like the computer, like the Python part of this course is the one everyone hates the most, is the one everyone is avoiding in class. Or at least in their practicals. And that kind of breaks my heart. If anyone would ever like to have a conversation with me about like Python, and if they're having troubles, like, please, I would love to have a conversation with you to help you get your foothold into programming, because it's such a glorious, beautiful subject. And there's just sort of some like little humps that you have to get over to start really appreciating it. So if you ever want to like have a conversation with me, I'd love to have you. I'm on campus, or we can do it through Zoom. Okay, so here's the motivation. So notice that like if we wanted to repeat something, we could repeat it, right? If I have a piece of code and I want to repeat that code 7 times, I can copy paste that code 7 times. Okay, but we need some provision to repeat like an endless amount of times. Can you think of any scenarios where you would have to really repeat potentially an infinite amount of times, where you can't predict ahead of time how many times you would need to repeat something? A live data feed, that's the right direction. Irrational numbers, well, that's more about printing. Well, like loop, again, like, so we can loop something if I know I only have to loop a finite many times. If I want to repeat something 100 times, I can just copy paste 100 times. But there are going to be situations where we can't predict ahead of time the number of times we have to loop. Yeah, so I suppose you guys have seen a little bit of sort of root finding. You're sort of using whiles, some tolerance. But okay, I have 2 examples here which are very easy and clear that you need to repeat an infinite amount of times to accomplish the task. So here's the 2. Suppose I prompt the user to, like, you guys have been working with input from the user. Now, suppose I want the user to input the letter X, and I'm going to keep asking the user, right, to input X. How many times do I have to ask the user to input X until they input X? Well, who knows, right? Possibly an infinite number of times you have to ask. So there's one scenario. And the second one is if you're playing random games, then you also need like a while loop. Suppose we're playing a guessing game, right? I roll a dice and you have to guess the outcome of the dice. And we repeat this game until you guess correctly. How many times do we have to repeat then? I don't know, possibly an infinite amount of times if the user keeps guessing wrong. right? So these are at least two situations where simply like copy pasting code a bunch of times is not sufficient. Like these are two situations where we very clearly need to loop infinite amount of times. Even in those numerical analysis ones that you guys have been doing, like we can work out ahead of time the max amount of iterations required to go into that minima. But in any case, right, we need some provision, we need some type of data structure or control structure in order to repeat something. So this control structure is called a loop, and it repeats code that belongs to it. Remember, belonging is indicated by like tab level, right? So if you have some type of control structure and you go up by 4 spaces, everything at 4 spaces is going to be included in that control structure. A while loop is a control structure that repeats something while some condition holds. So we have these type of flowcharts that we were using to describe these sort of branching. This is a flowchart that's going to represent looping, right? So this is how a while loops work. So you go in and some condition is checked. Remember last week we were talking about conditions, like any Boolean statement. So any predicate, any question that resolves to true or false, like is this car red? Right? So it checks some condition. If the condition is true, it will run code and then check the condition again. And if it's true, it will run code, check again, and it'll keep doing this, right? You see, it will loop, literally loop until the condition fails, and then it will continue with the program. So how many times does this code run necessarily? Like, are we guaranteed that this blue box code runs? Like, can this code be skipped, right? Well, it could be once, it could be twice, it could be 10 times, but it could be 0. If this condition is false, as soon as we get here, all of this will be skipped, right? This is sort of like a special if statement that returns you to the beginning of the if statement again to do these loops. And I don't want to think of like a while loop as only being required for like taking input, right? A while loop is something that's going to be like generic, that just like repeats anything, repeats any set of instructions, potentially an infinite amount of times. But like in our heads, we think about it as repeating a set of instructions while some condition is true. So the thing I'm trying to get across is that if that condition fails out of the gate, you can really skip everything. While loops can execute 0 iterations, anywhere between 0 and infinitely many. So this is the way the syntax looks. So I'll just remind you that you remove everything, including the angled brackets. So you remove the condition and the angled brackets, you put some proposition in there, and then you write some code at that indent level, and you're off to the races. You have a loop. Okay, so here's a very simple loop. It's doing something called accumulating. This is very typical when you're repeating something. Is it angled bracket or bracket are confused? Well, this isn't what you're looking at here on this slide isn't Python code. It's like a blueprint for Python code, right? So you have to replace this with some predicate, like the whole thing, like x greater than 0, right? And then you have to replace this with some code. So, right, this is just a way of saying like you have to, this is the pattern that you're following, but remove, so I'll write you a while loop. You can see my REPL. So I can say something like while, oops, okay, so say answer is equal to 0, right? While answer is less than 10, print answer, and then increase answer by 1. Okay, right, so this part here is what I called condition. Sorry, this part here is what I called condition, and this part here is what I called code, right? But it's just some sort of like generic way of describing, you know, put something in there. Okay, so here's a piece of code that looks very similar to the one that I just wrote, except that it's doing some type of accumulation. And so this is a very typical pattern when you're repeating something. You repeat and just keep adding, right? You're just summing something. So what will this do? So remember, like in order to interpret code, like there's no way of misunderstanding it, right? You just have to go through line by line and ask what the computer does, right? So what happens at line 1? Well, the name X gets the value 0, while 0 is less than 10. Is that true? Is 0 less than 10? Yep. Okay, so what does this do? This says X gets set to 0 plus 1. So X is now 1, and it goes into here. 1 is less than 10. So we repeat, X gets 1 plus 1. So it's now 2, 3, 4. So the question is, what is the value of X once this loop finishes? Yeah, it's either 9 or 10, right? This is the thing that I'm trying to deduce, right? So we have to be very careful with edges here. So what is the last value that X gets, right? So you think 9? Okay, so suppose X gets set to 9 here. Then we go up to line 2. 9 is less than 10. So X gets equal to 9 plus 1, which is 10. Then we go back to line 2. Is 10 less than 10? No. So then we break out of this and we check X and it's 10, right? It will be the last thing. Like X has to get set to the thing which breaks the condition. Does that make sense? And again, we just have to walk through line by line, right? We just say your X gets 8 plus 1. It goes up to here. Is 9 less than 10? Yup. So this executes. X becomes 10. We go back to 2. Is 10 less than 10? Nope. Here, 10. Right there. Again, there should be no confusion regarding how to interpret this Python code, provided you know like what the syntax means. But if you just go line by line, right, there's only one way to interpret these commands, right? Then Python's going to interpret them in a specific way, and so must you. So that's what I always want you to do, right? To start tracing these things by going through line by line and asking what happens at every single line. So we have another opportunity here. So here's a while true. So X is 0, while true, print X, and then increase X by 1. What's the first thing that gets printed? 0, right? X is 0. This is true. True is always true. We print X, which is 0, and then X goes to 1. What's the next thing that gets printed? 1. What gets printed after 1? Okay, so what's the problem with this loop? When does it break? When does it stop? Never, right? This never stops. This true is always, always, always going to be true. So this is called an infinite loop. And surely you may have stumbled upon infinite loops. So let's just go into here. While true, 1, 2, 3, 4, print 1. So it's printing once. So I have to hit Control C to stop this. So you should just know that Control C will break you out of an infinite loop, because surely you're going to execute an infinite loop. Wait, how do we know when to indent? Well, if you want something included in a block, you have to indent, right? So I'll go here. So while true, whoops. So see these 4 spaces here? So if this print 1, print 2, actually, I'm just going to put a condition here. So okay, so let's look at this. I'll do something smarter. So here's X equal to 0. While X is less than 10, I want to print X and then increase X by 1. And then let's print, actually, I won't do that. So I'm just going to increase X by 1. So this loop is going to loop itself 10 times. I'm going to print hello inside the while loop. And I'm going to print world outside the loop. It has to be 4 spaces, yeah, or a tab. Right, so see, so this while loop, right, is I said, like a while loop is a control structure for repeating code. So this begs the question, well, what code does it repeat? Well, it repeats any code that belongs to it, where belonging is denoted by like these spaces, right? So these 4 spaces here, right, mean that this is a code group. Do we have to? No, you don't have to. Like vertical space is meaningless. It is good practice to sort of use spaces to like separate to separate things. But again, this while loop has code. These two lines belong to it. So like this is one code block. So we can put line 8 on line 7. Yeah, sure. So if I put line 8 on line 7, does print world belong to that while loop? No, right? How about now? Yes. Okay, so let's run it to see what the difference is. Okay, so what happens if and just give me a moment. There we go. What happens if I run this? What do you expect to see? Right? You should always try and predict the output before hitting enter. Right? I expect to see 10 hellos and a world afterwards, right? Because what's going to happen? It's X is going to be 0. X is going to get set to 1, print hello world. 1 is less than 10, set X to 2, print world. 2 is less than 10, set X to 3, world. Okay, so you should see just down here, right? Those are 10 hellos and a world, right? And actually, let's just go ahead and I'll throw in the X there. Right, so you can see 1 hello, 2 hello, 3 hello, world. Okay, now I'm going to put this in. Right, so now you see you get hellos and you get worlds. Right, so that tab said, okay, now you get to be repeated with the rest of us. You now belong. Okay, but if I now do this, right, how many times do I expect hello and world to print now? Once. Okay, what is the value of X? Once we exit this loop, what exactly is going to be printed here? 10. Okay. 10 hello world. What happens if I take line 5 and go like this? I'll take that out and I'll put this in. Right. Okay. So here's you can't do this. Right, you can't sort of like take this out of the block and then put this into the block. This will give you a syntax error. So if I take that out and I sort of, if I just swap these, what's going to happen? Okay, so the thing I have right here, it's going to infinite loop, right? So it's going to print hello. It's going to print 0 hello an infinite amount of times. Right? Because I took the accumulator out. Okay, but this is very important, right? Like the fact that like spacing matters, and spacing is the thing that, because I always say we have a control structure, and this control structure is going to control a block of code. And whenever I say block, that means something at the same indent level, right? And you can, these things can be embedded in one another, right? So I'm going to have this while loop, and I can have another while loop like this. Okay, so this while loop, right, has this as its block. This while loop has this while loop in its block, right? So it's everything at 4 spaces and everything else, right? It's everything at least at that 4 indent, not exactly at that 4 indent. Okay, so you need to go play around in this a little bit, but I have plenty of examples, so hopefully it will help straighten you out. Okay, how about this one? X is 0, while false, print X, and then increment X. Nothing prints, right? We talked about this. This is going to fail immediately, right? So while loops don't necessarily have to like execute an action. Okay, but that's not really great, right? Sometimes we do want to perform at least one action. Like at the beginning of class, I said, take input from the user. So if you want to take, so suppose you want to take input from the user and ask if the user input a number. Like the code would somehow be like, ask the user for input. It's continually ask the user for input until they input something right. So this do while is sort of the reverse of the while do. So we need to introduce this break statement so we can get this sort of do while loop. So we can have like these both versions of this loop. So let's study this piece of code here. So the break keyword just sort of terminates the loop immediately. So what is this going to print? While true, okay, so we for sure enter the code block. print hello. We're going to print hello, that's for sure. And then we're going to break. Stops the loop. So what prints here? Yeah, just hello. Okay, so we've shown while loops. So we have a while, this is true, do something. And now we're going to have a do while loop, which basically just moves the condition check to the end of the code rather than to the beginning. Right, so it somehow works like this. So do some code, check a condition. If the condition is true, do the same code again. Check the condition, do the same code again. And once the condition fails, continue with the program. So you have these do whiles and while do's. Yeah, so in a do while loop, the code is executed at least once, which is not the case with the while do. Right, so both are sort of necessary. But the do while loops don't so some languages have do while loops built in, Python doesn't. So I'm going to show you how to simulate it. Is there a limit to the number of while commands inside? Oh, no, you can have as many as you like. You can while as far as you like. Now, once you start having a lot of embeddings, that starts to become a problem. But yeah, no, there's no limit as to how long these lines can be or how many embeddings you can. It's very hard to maintain. The code can start getting quite unreadable. Okay, so a do while, sometimes called a repeat until. This is just sort of like, it's a while loop, it's just a little bit of a variant of the while loop. And it has syntax that sort of looks like this, although this doesn't exist in Python. I'm going to have to show you how to simulate it. It's easy, though, to simulate. You say, so remember, one and true can be exchanged. So I just want to show you that you can put a 1 there. And this is the same thing as while true, in case you're looking at other people's code. So there's like program style, and some people prefer saying while 1 to while true. I'll use true just because it's more clear. But I just wanted to show you once that sometimes you may see a while there. So while 1, while true. Okay, so we pass. Increase x by 1, so x becomes 2. Is 2 greater than 0? Yep. So we break. And then we check x, and it's set to 1. So notice that x retains its value. But here's a while loop which had to perform its block action like at least once. Right, so again, we have whiles and do whiles. And we'll do some examples to try to flesh this out a bit. Here's an alternate way. You can write it like this. Don't look too carefully at this. I'm sort of hesitant to show you some of these shortcuts, but okay, here it is. Here's a shortcut. You can write this if statement on one line if you want, but let's not be too concerned about this. Okay, so you've used input? So input is the thing that allows us to ask the user to input something. The thing that is input is always going to be a string. So sometimes we're going to have to convert these strings to numbers if we want to treat them like numbers. So the first thing I want to do today is write a function. Let's call it foo. That takes a target. And I want to play a game where the user just keeps getting prompted to input a number until he guesses the target. And once a guess is made, we're going to say the guess is too high, too low, or we got it and we break. So this will give us a good chance to practice. So I'm just going to go into here. So I'm just going to create a function, foo. It's going to take in a target, which is going to be an integer. And what did I want to do? For each guess, the function should print and to put a number, return the number of guesses required. Okay. So we're going to return an integer. Okay, so let's start programming. So first I need number of guesses. And so far the number of guesses is 0. So now I want to prompt the user for input. Check if the input is the correct guess. Well, maybe we can write this, right? So prompt user for input. Check if input is the correct number. And then send appropriate message are the 3 things I want to do. Okay, so how can we prompt user for input? Sorry, what's the target? The target is the guess, right? So the user doesn't know, has to guess some type of number. So the user is trying to guess target. User doesn't know what target is, right? So it may be the case that like I call foo of 100 and then the game is like us trying to guess that value for 100, right? So but the user doesn't have access to this target. It's just the thing that we're trying to guess. Okay, so number of guesses is 0. So prompt the user for input. How can I prompt the user for input? So that's something like input, right? Guess a number. Okay, so this input I'm going to put into guess, but what do I have to do to this input in order to check it against the target, which is a number? Have you guys not defined functions yet? Have you guys defined functions? Is this something new to you? Okay. For those unfamiliar with functions, you should watch my lecture on functions from CSSE 1001. But okay, quick prompter on functions. Remember math? Remember in math how you could have like a function like f of x is equal to like x squared plus x plus 1. I'm just gonna have another. Let's take that out. Okay. So in math, you could have this, that this is a function, right? So when we say something like f of 2, right, this means do this, which is 4, 6, 7. We can even have functions of like more than one variable, right? X times y plus x, right? And then you know here like f of 1, 0 is 1 times 0 plus 1, which is 1. Okay, so is everyone comfortable with like these type of functions? Okay, so all a function is something that takes input, one or more inputs, and then gives you back something. Can we agree on that? Okay, so in order to like explain a function to Python, I just need a way of telling Python, here's the things that you have to give me via this name, and here's the thing that I'm going to give back. Can you agree on that? Those are the only things that we need. Right, okay, so let's do this. I'm going to change this to G just so we can have different ones. So this is how this works in Python, right? I say I want to define something, a function called f. This function is going to take x, and this function is going to return x squared. Oh, I forgot which one works like this. Okay, so I'm just going to put that into here. And then if I open up my Python, okay, now I have a function f, which I can just evaluate like, oops, normally. What has happened? Whoops. I have a new computer and it sort of like panics a bit. Right, so you see how I can do something like that? That's not possible. F of 2, f of 101. How can I f of 101 squared? Oh, that's I knew I was using the wrong exponent. Let's try that. That seems better. Yeah, def is like only, it's just something that says to Python, this isn't a name. This isn't a name of a value. This is going to be the name of a function, right? So when we look down here at this foo, this is going to be the name of a function, which is going to take an input, right? Which in this block, we're going to call target. It's going to be an integer, and I'm going to return an integer. Okay, so back to this. Wait, is while a function? No, while is a control structure. Can we just do def target like this? Well, what does that mean exactly? Like what you're basically saying, why can't we do this? But because maybe we'd like to have more than one function, right? So these things have to have names. No, you have to give the function a name. Randy, like that should be clear, right? You can't have a nameless function. How are you supposed to call it? Yeah, def foo target would be fine, right? So if you want to take these out, right, this will also work, okay? But the more, like, you're going to screw yourself later, right? Because now it's not clear what this is doing, right? When I put these in, when I say target should be an integer and this should return an integer, right? This is like saying this function f, right, takes a real number and returns a real number, right? A lot of these things are just analogs to what we have in math, right? And these functions are always going to be mappings between two sets, right? And this one is like indicating what the first set is. But if you don't want to put it in, we don't have to put it in. It just makes the code a little bit less readable. Okay, so we have the number of guesses equals to 0. So I want to prompt the user for an input. So they're going to guess a number. I saw some recommendation that we use float, but would you say float is the right structure here? Like, are we ever going to like have half a guess? No, right? So what should I read this in as? Int, right? Okay, so guess a number. It's going to be an integer. And then check if the input is the correct number. Okay, if guess is equal to the target, we want to say print, you did it. Else, oh, and then I want to return number of guesses. Elif, right? Else if the guess is less than the target, then we print too low. And then else, right? This is the last thing where guess is bigger than target. It's the only thing that remains. Print too high. Okay. But we want this right here. This needs to be repeated, right? This is something that we want to. Why is there a hash? Have you guys not seen comments yet? Oh, here? Because this is a comment, right? This is else, right? This doesn't actually need to be here. Right? I put a comment here just to basically say, look, like this actually is the condition. Guess is greater than target. This is the only possibility at this point. Yeah, sometimes I'll just put it in to like, so when I'm reading this code, like it's clear. Yeah, so sometimes I just, anything in green doesn't have to be in input. Okay, so where was I? Okay, so this we want to repeat, right? So which one should we use? We have do while and while do, right? Do we want to do something at least once in this instance? Yes, okay, so we should use the do while. So we have to simulate it. So what I'm going to do is I'm going to say while true, right? Whoops. We're just going to repeat all of this. Okay, so while true, get a guess. If the guess is the target, then return, which means that like the function will leave. We'll break this while loop. So we don't actually have to write a break. Why are there 8 spaces here? Because this is a control structure in a control structure. Line 11 here. Well, I don't, again, that's a comment. You can ignore all of these lines. Oh, so, why are there 8 spaces? Because everything has to belong to the function, right? So what belongs to this function, right? Well, everything at that indent level, everything here. And what belongs to this while loop? Everything here. Yeah, so I like this is extremely important, right? That like the blocks of code have to be sort of grouped together. Like this grouping is critically important, right? Because we're learning about if statements and loops and functions, right? So Python has to know what lines of code belong to what, right? So in a function, everything's going to be at 4 spaces, right? Because everything has to be included in the function. Moreover, you have to move in again, right? If you put a control structure in a control structure, right? So every time you put a control structure in a control structure, you're going to have to go out more. But like, this is great. Like you keep asking these type of questions, right? So we can resolve these things. Doesn't the colon? No. Space colon does not automatically do that, right? Spaces in Python matter, right? They define what belongs to what. Other languages like C use curly braces where the spacing doesn't matter, but in Python, the spaces definitely matter. So the colon, nothing is done automatically. No. Right? If I could say, define foo of X, right? Return X plus 1. Python's not even going to accept this. Right? It says this is not at the correct indent level. Can we call the function again in the function instead of while? Sure, but that's recursion and I really don't want to get into it. But you can. You can call a function within a function, right? Like for instance, factorial of X, if X is 0, return 1, else return X times factorial of X minus 1. Like this, that will work. Okay, but I don't want to get into it because self-ref, this is confused. Like people's minds get broken when you start talking about recursion. But I teach Comp 3400. That whole class is on recursion. Recursion is like extremely elegant and a beautiful way of solving problems, but I don't think we actually get to talk about it this semester. I have to keep things nice and simple. Oh boy. Okay, so let's run this now, right? So I suspect that this is going to work. Okay, so I'm going to call foo, which is going to execute this block of code, right? So I'm going to close my eyes and I'm going to like type in a number. I'm going to hide it. Okay, I didn't see what number I picked. So let's try this guessing game. 1,000, too low. 2,000, too low. 1, 2, 1, 2, 3, too low. 1, 2, 3, 1, 2, 3, too high. What about half this? Whoops, I have to do an integer division. Whoops. Oops, it broke. So what happened is I gave it a float and it couldn't. So now I have to call the whole thing again. What number did I pick? I was never going to guess that. Only thought an int takes a certain number of bits. Like, no, you have arbitrarily large integers on with Python. Right? Oh my Lord, you think that number is massive? That number is not a massive number. So that's a 64-bit integer. That's quite easily represented by Python. Like I can take this. I can go pretty crazy. I can say that to the power of 2 to the power of 2. Right? That's still fine. To the power of, it's 50. Okay, now this is less fine. But no, with Python, you can get arbitrarily large integers. Well, it's not your bad, right? It's just Python's a very flexible system. Okay, so this was like a guessing game that plays out. I have the code in the slides for you, so you don't have to ask me for the listing. What about number of guesses? Oh, okay, so I just didn't play the game properly. Foo, 101, that's my favorite number. Guess a number. 100, too low. 102, too high. 101, you did it. Oh, yes, I should probably increase the number of guesses by 1. Thank you for that. So let's try again. Foo of 101. Guess 1, guess 200, guess 101. You did it. 3 guesses. Perfect. It's just a simple piece of code to try to illustrate some of the stuff that we've done before. But like this is really informative, like asking these questions like, why isn't this tab, right? I like this. This hour really flew by. Okay, so I'm going to leave you some of these as exercises. So write a function called bar, and I want you to prompt the user to guess the roll of a 6-sided dice. Now, for this, you have to use random numbers, and I'm just going to skip a bunch of this stuff because it's really not that important, right? You technically, I'm not really supposed to show you anything that's not in the book, but like, I don't know, random number generation is interesting. So the computers are deterministic machines, right? They can't make random decisions, right? They can only do deterministic things. So computers can't actually generate random numbers. they generate something called pseudo-random numbers. Like you'd really need to build a machine to generate random numbers. So I think if you fire an electron at two slits, nature is going to decide which slit it goes through truly randomly, uniformly randomly. So there's this weird behavior with random numbers in Python or in any programming language, and they're not included in the Python standard library because random number generation is fairly difficult. So we have to call libraries, and you guys are used to this. You've called in Pylab, right? So all these import statements mean is saying, I would like to use something that's not part of the standard Python library that some other programmer wrote, right? So I can just say from random import random integer. So it gives me this piece of, gives me a function which generates a uniform random number between 1 and 6, some random integer. Okay, so here's the funny thing about random numbers. So random numbers on computers, you have to give it some type of seed, right? It's a function, you give it some number and it will start generating random numbers. So if I give random a seed, and then I start asking for random integers between 1 and, I don't know, 10,000. So the first number is going to be 2,202. The next random number, 9,326. Now here's the confusing part. If I random seed again and start asking for random numbers, you're going to get the same random numbers back. So this may be hard to understand, but like the sequence of random numbers is totally reproducible. But think about it this way. If you knew like 1,000 of these numbers, and I asked you to predict the 1,001 next number, it's pointless. Like having all of this previous information is pointless. So in any case, pseudo-randomness is fairly weird because it doesn't seem random, but it's sufficiently random. So I just want to go into here and show you, right? I can say from random import rand int, right? And now I can just start generating random numbers. See? So I just want you to use that. And I want you to write a little piece of code that like basically does the same thing we were doing with the guessing game, except I want to prompt the user. Well, here's one of the answers. So while true, like I rolled the dice, so I got a random number between 1 and 6. Then I asked the user to guess that number. And if he guessed right, then we break, and otherwise we repeat. So don't look at this, try to implement it yourself tonight. So here's a couple of other exercises for which I don't think I gave the answer. So I want you to write a function that prints the result of 6-sided dice rolls until a 6 is rolled and return the number of rolls required. And I want you to write another function that accumulates the result of dice rolls until some threshold is met. So like you roll 1 and then you roll 3, so you get 4, then you roll another 3, 7. Because these are interesting questions, right? So there's a field called stochastic processes where we want to answer questions like this. So suppose you write a function that prints the results of 6-sided dice rolls until a 6 is rolled. You can start asking questions like, what is the average number of rolls that I have to roll in order to roll a 6 on average, right? You can do some experiments, right? Or what is the average number of rolls of a 6-sided dice that I have to roll in order to sum to 100? Like on average, how many rolls is that going to take, right? So maybe you can ask yourself some of those questions, but like those stochastic processes, that's an interesting thing to think about. And using a computer, actually, you can resolve some of these questions. So someone next class, I want you to tell me what is the average number of rolls you have to roll a 6-sided dice in order to accumulate past 100. And you can write some programs to simulate it. Was that clear enough, that instruction? I've seen all the questions have stopped, which usually means everyone have stopped paying attention. Right, but this is good for like you Psi 1000 kids, right? Like, right, you need to use a computer to answer this question, right? On average, how many times do you have to roll a dice so that the accumulated dice rolling is in excess of 100? And I actually don't know the answer to that at the moment. I'd be curious. And I'd be curious to know if your results sort of match up. Okay, so next week, we're going to talk about arrays, which are just sort of groups of objects, like a list of numbers. and how to sort of work with that list. But I have some time now if I can address any of your questions, if you'd like. You guys can dip out. Again, you feel free to watch my lectures from this morning. What did I do this morning? Strings. I did strings and I did for loops, even though you guys aren't supposed to use for loops. Yeah, no problem. And do come and visit me if you guys ever are stuck on anything. Like I'm here every day and I'd love to help any of you sort of figure out where you're stumbling in order to like get you going in the right place. Yeah, no problem. No problem. You guys have a nice weekend too. Sorry to clarify, true means 1. Anything that's not 0 is true. Right? Bool -1 is true. Bool of this is true. Bool of 0 is false. All right, so I can say while brah. Right? And that will be interpreted as true. It's just some programmers prefer saying while 1 to while true. I just wanted to show you, right? In actuality, like I can put a string here, all right, and that's going to always evaluate to true. Can you please go through question 4.8? Which one's 4.8? Like on my slides? Yeah, my videos are on YouTube. I can find that for you right now. If you post question 4.8, I can talk about it. I just don't know what question 4.8 is. Trying to find my landing page here. I don't have access to that MyPyTutor stuff. Can you just, if you post it, or if you just tell me what the problem is, I can talk about it. What is return? Like here? Okay, so back here, remember how we're talking about these functions? Right, so in math, this is a function called f, which takes 2 and gives back this, right? So in Python, I need some way to duplicate that, right? So this was the beginning, right? So this basically is this part. And now we need to like somehow do this part. And the equal part is done like this. Right, so this basically, this return, you can almost think of like as an equal, right? But we want to maybe do things on like separate lines. Right, so now that like these things have to be on multiple lines, the equal doesn't make any sense, right? So now I need some word to say, this is the thing that you should hand back. All of this other stuff was sort of just rough work. Does that make sense, Michelle? Perfect. Yeah, it's something called the reserved word. Right, so you just should note that you can't use return. You can't use return the same way you can't use if, right? You can't assign stuff to them. But yeah, that's all the return does. It's like, this is the thing that you should, like really the thing I calculated that I want you to hand back. And you won't have access to any of these things outside. Like here, A doesn't exist at this indent level because it belonged to this block. These are excellent. Like I love these questions, right? We're starting to figure out what the stumbling blocks are. And it's usually just stuff like, oh, why don't, silly things like spacing, right? All of you are quite capable of doing this once we work out some of these little edge case problems. Okay. Does your web work, is it for grades? Am I committing an academic offense by doing this? Do you guys get marked for your web work, or is it just for practice? No, it's not graded. Okay, I'm not committing an academic offense. Okay, so I'll just, people can leave if they want, but I'll spend the next 10 minutes doing this. New share and this. Where did you go? Here. Can you guys see the problem statement, or what is happening? Can you see the problem statement? What do you see on your end at the moment? Problem statement? Okay. Remember an introduction to loops where you added numbers together? No, but sure. In this exercise, you will be multiplying numbers together. When adding numbers together, you start with 0 and add the first number to it, then the second, and so on. But when you multiply numbers together, you start with 1 and multiply it with the first number. Oh, okay. So if you have numbers like this, I suppose you want to like add those together. So you would start with like some, okay. Let's do this. Definition, summit. And we're going to be taking I think this is taking a list of integers. Or what's the problem statement? Oh, okay. We're taking user input. Okay. I was going to call it foo then. We take user input. So while true, I want to take user input. So this is, I don't know, a number. So this is gets input, enter your number. Change this to an int. Okay, so they're basically saying just, accumulate the numbers being entered by the user until they do what? When do I stop? The user wants to multiply many numbers together. Write a program that will keep asking the user for numbers until they enter 0. Okay. While true, enter a number. If number, if not number, right, which is the Pythonic way of checking if number is equal to 0, then I want to finish. Okay. Return the answer. Okay, so answer is equal to 0. So you input a number, and then you say answer is equal to answer plus number. Oh, sorry, I did that wrong. You input a number. If the number is 0, you escape. Right, so that's what this means. Else, you like add that number to answer and repeat. So let's give this a try. So I'm going to call foo. Enter your number. 1, 2, 3. And now if I hit 0, what do I expect? Well, 3 plus 2 plus 1 is 6. 6. Okay, so have what I done just made sense? Or that's the thing you did last time, right? Adding numbers together. Mr. Lee, does this make sense, what I've written? You sure? Like, I don't mind if you like say that doesn't make any sense. Okay, so you have to tell me, so these lines are numbered. So you can go ahead and tell me what's confusing. And if you like, I can stop the recording and you guys can come up on video so we can work this out. Okay, so I was going to go ahead and I'm going to stop the recording.